Ever wonder how roller coasters calculate exact speed? Or how we find a hill's steepness right where you stand? It all comes down to the derivative. Today, we'll define the derivative, grasp its limit definition, and understand its power in finding instantaneous rates of change. We start with average rate of change. Imagine driving a car. Average speed is total distance divided by total time. Visually, this is the slope of a secant line connecting 2 points on a curve. The formula is f of x plus h minus f of x all divided by h. Next, how do we find speed at one exact moment? Average speed needs 2 points. But we want just one. We use a clever trick. Make the distance between our 2 points infinitely small. Watch the secant line pivot and transform. As one point approaches the other, the secant becomes a tangent line. Its slope is the instantaneous rate of change. This getting closer and closer is precisely what a mathematical limit does. Limits help us zoom in infinitely close. The derivative, denoted f prime of x, represents a function's instantaneous rate of change at a specific point x. It gives us the slope of the tangent line to the curve at that precise spot. This is the heart of its power. We bring our 2 points infinitely close. As h, the horizontal distance, approaches 0, the average rate becomes instantaneous. This formal definition is f prime of x equals the limit as h approaches 0 of the quantity f of x plus h minus f of x, all divided by h. Think of a magnifying glass. We're zooming in so close on the curve that it looks like a straight line. And the derivative reveals that line's slope. Let's apply this by finding the derivative of f of x equals x squared, using our new limit. Definition. This function describes a parabola. First, we substitute f of x plus h and f of x into the formula. The limit as h approaches 0 of x plus h squared minus x squared, all divided by h. Expanding x plus h squared gives x squared plus 2xh plus h squared. The x squared terms cancel, leaving 2xh plus h squared. We then factor h from the numerator, giving h times the quantity 2x plus h. Canceling h leaves 2x plus h. Finally, taking the limit as h approaches 0, we are left with 2x. So, the derivative of x squared is 2x. As a quick check, what does f prime of x equals 2x tell us about the slope of the parabola y equals x squared? At x equals 3, it's 6. Today, we unveiled the derivative, a cornerstone of calculus. We saw how moving from average rates to instantaneous rates is achieved by taking a limit. The limit definition. F prime of x equals the limit as h approaches 0 of the quantity f of x plus h minus f of x all, divided by h, is your key. This powerful tool helps us understand everything from acceleration to optimization. Keep exploring, and you'll see its magic everywhere.